Hello everyone, this is Mrs. Figueroa. So today we're going to be starting our new unit on polynomial functions, graphing them specifically, and today I'm going to be going over part 1. There are 3 different parts of the graphing, so today we're going to go with just the basics. So our objective students will be able to graph polynomial functions. I do want to apologize ahead of time in case if there's noise in the background. I do have my kids playing with their toys. So they might make some noise in the background. And I do have a dog at home, so I don't know if they're going to bark either. So I apologize ahead of time. Hopefully we won't get disrupted too much. Alright, so first thing we need to know is the end behavior. So in end behavior, you should have learned, I hope you learned this as like Math 1 and then you review it again in Math 2. And again, we're going to be going over end behavior in Math 3. So kind of the basics that I like to go over with my students is like the notation, like positive and negative infinity and what all that really means. So if you think about the x-axis, going to the right side, this is going like 1, 2, 10, 20, 100, 1,000. It keeps getting closer and closer to positive infinity. So I like to draw on my x-axis a positive infinity. I just kind of just put like a sideways 8 is your infinity, but I personally write my a's with 2 circles. So when I write my infinity, it looks kind of funky because I just do 2 circles next to each other. But anyway, so that's positive infinity is going to the right side. And then if you think about the left side, it's going closer and closer to the negative. So negative 1, negative 10, negative 100, negative 1,000, 10,000. It keeps approaching negative infinity. Okay, so my left side approaches the negative infinity and the right side approaches the positive infinity. Likewise, for my y's, going upwards, I'm going to like 1, 10, 100, 1,000. It keeps getting closer and closer to positive infinity. And then going downwards, so going down, I'm getting to negative 100, negative 1,000, and so forth. It's approaching negative infinity. So when you see these notations with positive infinity, negative infinity, and then it'll say like x approaches positive infinity, f of x approaches negative infinity. You kind of have to figure out what that means. So I feel like using this little notation next to the x and y axis helps a little bit for my students. So let's say you end up with something on this side with an arrow. So think about where your x is approaching. Your graph is going this way, so it is approaching the right side. And since the x's are approaching the right side, we say as x approaches positive infinity, because the right side is positive infinity, what are your f of x values or your y values doing? So f of x approaches, it's going upwards, so upwards is a positive infinity. Okay, so as your function is going to the right, as your x values are going to the right, your function is going upwards. So when we do your end behavior portion, you're going to have everything here except for the highlighted portion. So we read this as x approaches positive infinity, the function approaches positive infinity. And if I look at another example, let's say my function ends up looking something like this on the end, because the whole point of end behaviors are looking at the ends of the graph, okay? So let's say I have something over here, and notice is going to the left side. So going to the left side, we would say as x approaches negative infinity, because again, this is talking about the left side. The function f of x approaches, and if you notice it's going upwards, so upwards again is positive infinity. I'm sorry, I don't need a comma there. this is going upwards, okay? So as the function goes to the left, as your x values go to the left, your function goes upwards. And let's say I have something that looks like this. On my ends, this is also the left side. So I am going to say as x approaches negative infinity, because negative infinity is representing the left side, my function f of x is approaching, this time it's going downwards, so downwards is a negative infinity. Okay? So as your x values are going to the left, the function is going downwards. And if I have an example going like this, then this is the right side. So as x approaches the right side is positive infinity, the function approaches downwards, and downwards is a negative infinity. So again, as x goes to the right, the function goes down. So basically how you read this is as x approaches positive infinity, the function approaches negative infinity. But what this really means is as x goes to the right, the function goes down. Okay? So in a nutshell, that's kind of what end behavior represents. And sometimes you have a rare occasion when you get to asymptotes. In asymptotes, then the function is approaching a specific number. And again, I apologize for my kids in the background. But anyway, so when we do get to the asymptotes, we'll just kind of go over that when we get to it. But I don't want to confuse you guys on that since it's not relevant in this lesson. All right, so if we look at the concept, we have when a function has more than one of the same zero, this is called multiplicity. So an even multiplicity, so 2, 4, 6, 8, creates a relative maximum or minimum at the 0. And then if we have odd multiplicity, like 1, 3, 5, 7, and so forth, oops, my bad, this says greater than 1, so not including the 1, creates a point of inflection at that 0, meaning a curve through that point that creates a change in concavity. But in Math 3, we're only going to focus on even multiplicity. We're not going to go over the odd multiplicity examples. So we have 3 different graphs here. In my first example, I have 3 zeros, negative 3, 2, and 4. And notice I don't have any multiplicity because I don't have more than one of the same zeros. So then in this example, you would just cross the x-axis all 3 different times for those zeros. In my next example, I have my real zeros 1, 1, and 6. So notice 1 shows up twice, so then 1 has a multiplicity of 2, and then 6 only shows up once, so 6 has no multiplicity. And I just noticed this is wrong here. This should be a 2, not a 1. Because if you look at the x-axis, it's actually at 2, not at 1. So it would be the 0 of 2 has multiplicity of 2. So if you notice on the x-axis here, I didn't cross the x-axis. It created a maximum at that 0. So that's what the multiplicity does. You don't cross the x-axis, it creates either a maximum or a minimum. If I look at the next example, I have negative 5, 2, 2. So negative 5 shows up twice, so it has multiplicity of 2. And then 2 shows up twice, so it has multiplicity of 2 also. So if I look at the x-axis, negative 5 here, I didn't cross the x-axis. It created a minimum this time. And likewise with 2. It did not cross the x-axis, so it created a minimum at 2. So that's what multiplicity does. Alright, so for today's graphing, these are steps we have to follow. First, you need to draw your x and y axis and scale appropriately. And then you want to plot your zeros, and then you want to take note of any multiplicity, because remember, multiplicity would either create a maximum or a minimum, so you would not cross the x-axis. Then you want to plot the end behavior, and then step 4 is to sketch the graph from left to right. So if we look at the first example, It says sketch the graph of each polynomial function given the end behavior and the zeros. So my end behavior, which is kind of what I was talking about in the beginning of the lesson, I have as x approaches negative infinity. So think about how I have this here. I'm going to try to draw it really fast. Right goes to positive, the left goes to negative, up goes to positive, and then down goes to negative. So this right here, as x goes to negative infinity, x is the x-axis, so negative infinity is going to the left. So this portion, let me try to color coordinate. This portion is talking about the left side, because as x goes to negative, it's the left. Y goes to positive. So the y-axis is going to positive, is going upwards. So my y value is going to go up. And then for my other side, I have as x approaches positive infinity. So positive infinity on the x-axis is going to the right side. Y goes to negative infinity. So if I look at the y-axis going to negative infinity, it's going to go down. Oops, sorry. And then my real zeros are -3, 1, and 6. So the first thing I want to do is go draw my x and y axis. And this is just a sketch. So it doesn't have to be perfect. I wish let me see this. That's fine. I was going to go try to make my pen a little bit darker so you can see it. But no big deal. Anyways, so you need to have some kind of a scale. My zeros are -3 and it goes all the way to 6. So I have to go by 1. So 1, 2, 4, 6, and then -2, -4, -6. I really don't need my y-axis, but I'm going to go to 3 and -3 here. So that was my first step, draw your x and y axis in a scale. And then step 2, plot your zeros and note any multiplicity. So notice here I have no multiplicity. None of my zeros are repeated, so I'm going to go plot my zeros. I have to go to -3. I have a +1 and a +6. And then I want to plot my end behavior. I'm going to, because I know it's going to connect my last points. So look at the end behavior. I have the left side is going to go upwards. So my left side of the graph needs to go upwards. So I'm going to draw my arrow kind of closer to the dot here. I'm going to draw my arrow up here because my left side is going to go up. And then my right side of the graph is going to go down. So if I go to the right side of the graph, I'm going to go draw an arrow down here because it's going to go downwards. Okay, so I plotted the end behavior and now I have to sketch the graph from left to right. So I'm going to go start over here where I have my arrow, and I'm just basically going to go connect my dots. I have no multiplicity, so I have to cross the x-axis every time. So I cross the x-axis at my 0, and then I have to go back up to cross at the other 0, and then back down to cross the other 0. Okay, how far down and then how far up you go doesn't really matter too much. The important part of this lesson is that you cross at the correct x-axis, x values at the zeros, and you have the correct end behavior. Okay. So that's the sketch of the graph for the first example. If I look at the second example, I'm going to do the same thing here. This tells me as x goes to negative infinity, so negative infinity is the left side, it's going to go y goes to negative infinity is y goes down. And then as x goes to positive infinity, it's going to be the right side. Y goes to positive infinity means it's going upwards. So the left goes down and the right goes up. So then my real zeros, I have -5, -3, 0. None of them are repeated. So notice I have no multiplicity in this example either. So I have to go draw my x and y axis with a scale. Again, please use a ruler when you guys draw your graphs, but I don't have a line tool in the program I'm using, so I'm just kind of freehanding it. But please use a ruler or a straight edge of some sort. Okay, so anyways, I'm gonna go draw my scale. I need to go from -5 to 0, so I'm just gonna go by 1. So 1, 2, 3, 4, 5, 6, -1, -2, -3, -4, all the way to -6. And my y-axis is just a sketch, so I don't know how far up or how far down to go. So I am not gonna put a y-axis scale. All right, so that was step 1. Step 2 is to plot the zeros. So my zeros are at -5. I have a -3, and I have a 0. And then my next thing I want to do is draw my end behavior. So I have left side goes down, so my left side is going to go down, and I like to go at my last 0. I'm going to go downwards, and then my right side is going to go up. Next to the last 0, kind of shifted just a little bit, I'm going to go draw my up arrow. The left goes down, the right goes up. So I'm going to go cross, 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 because none of those have multiplicity, so that means you cross the x-axis every time. All right, next example. I have x goes to positive. So x going to positive, that's the right side. Y goes to negative, means down. And then as x goes to negative, means the left side. Y also goes down. So it goes down because it's negative infinity. Okay? So notice the x's always tells you left and right, and then the y's tells you up or down. And for the x's, one of them always goes to the right and the other one always goes to the left. And then your y's, you can have both of them go down, both of them would go up, or you can go one going up and one going down. I apologize for my kids yelling in the background, but it is what it is. Okay, anyways, so let's go draw our scale. Again, I apologize for not using a line tool. And then I'm just gonna go by 1, so that's 2, 4, 6, -2, -4, and -6. All right, so I have my x and y axis and I have my scale. So next I'm gonna go draw my zeros. Notice -5, -1, 1, 4, none of them are repeated, so I have no multiplicity. So I'm just gonna go put a dot next to or on that 0. So -5, I have a -1, a +1, and a +4. And my end behavior, I'm just gonna put an arrow. So the right side, next to my last 0 on the right side, I'm gonna put an arrow shifted a little bit next to that one. And then my left side is also going to go down. So next to my last 0, I'm going to put a shifted arrow slightly a little bit towards the left. Okay? And no multiplicity, so you cross the x-axis every time. So cross, 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 cross. And then, very important, you kind of have to think about the 0 being like a bridge, kind of. So if there is no bridge, you can't cross the x-axis. So a common error that people do for my students is sometimes they do extra loops. But if you don't have a 0, you are not allowed to cross the x-axis. So please be careful. Each of your zeros is kind of like a pathway to cross the x-axis, okay? If there is no 0, you're not allowed to cross the x-axis at that point, okay? All right, next example. I have x goes to positive infinity, so which side is x going to positive? Think about the x-axis is approaching positive infinity. That is the right side. y approaches negative infinity, so on the y-axis, approaching negative is going downwards. And as x approaches negative infinity, that's talking about the left side, the y is approaching negative infinity, so it's also going downwards, okay? My real zeros, notice I do have multiplicity this time. The multiplicity is for the 3. So I have -2 and 0 have no multiplicity. And then 3 has a multiplicity of 2. So 3 is actually going to create a max or a minimum. Anytime you have this multiplicity, this is a max or min at that 0, okay? So if I go draw my x and y axis, I need to change the thickness of my pen, but okay. Anyway, so I have 1, 2, 4, 6, -2, -4, and -6. All right, so the ones that have no multiplicity, you're not going to cross the x-axis, so I'm just going to put a regular dot at -2 and my 0. And then 3, however, has multiplicity. So in order for me to distinguish which ones have multiplicity, I like to put an asterisk to remind me that I'm not allowed to cross the x-axis there. It's going to be either a min or a max, depending on which way my end behavior goes. All right, so now I have my right side, it goes down. So if I go to the right side of the graph, at my last 0, I'm going to put a down arrow, shift it a little bit more towards the right. And then my left side also goes down. So I'm going to put an arrow going downwards, shift it a little bit towards the left side. And then no multiplicity means I'm going to cross the x-axis. And then I have to come back down. It's no multiplicity, so I cross. But 3, however, has multiplicity, so I have to dip back down. That is a maximum in this example. So notice I didn't cross the x-axis at the 3 because it created a maximum, okay? No multiplicity, you cross the x-axis. Multiplicity, you do not cross the x-axis. It creates a max or a minimum. All right, next example. Okay, in this example, I have x goes to positive is the right side. Y goes to positive is up. X goes to negative is left. Y goes to positive means up. And then if I draw my x and y axis, and I need a scale 2, 4, 6. Okay, so notice this time I have -5 has multiplicity and 4 also has multiplicity. So they both are going to be either maxes or mins. So at the -5, I'm going to go put an asterisk. And then at the 4, I'm also going to go put an asterisk. And then my right side, going to the right, I'm going to put an up arrow. Sorry, I got my daughter here with me. And then my left side is going to go up. So starting from left to right on my left side, I'm going to have to go downwards, but I have an asterisk, so I got to go back up. No, don't cross the x-axis, and then back down. Don't cross the x-axis and go back up. I apologize. My daughter is very distracting. I probably shouldn't do these videos when I'm at home. But anyways, so the -5 and the +4 both end up being minimums this time. I'm trying to... Alright, which brings us to our last example. And I think I'm going to just do it and show you the solution. So you can pause the video and try this on your own, or you can just keep watching for the solution. All right, so in this example, I had x is positive infinity, so that's the right side. Y goes to negative is down. X goes to negative is the left side. Y goes up is the positive infinity. My real zeros, I had -1 with no multiplicity, and a 5 had multiplicity times 2. So I just put a regular dot on my -1 and an asterisk on 5 because it has multiplicity to remind me that it is going to be a min or a max. And then I drew my end behavior, the left side going up, the right side going down. So a regular dot means I cross the x-axis and then I have to go back up. And then my asterisk means I don't cross the x-axis, so you dip back down. So 5 ends up being a maximum in this example, okay? And that is the last example for today. Thank you guys for watching, and again, I apologize if it was distracting with my daughters in the background.